13.8 billion years ago, the universe began. In a single, incomprehensible instant, everything that exists today, every atom, every ray of light, every fundamental law of physics, emerged from what was essentially nothing. In one moment, there was no space, no time, no matter. In the next, there was everything. Just how such a thing is even possible remains perhaps the greatest mystery in all of science, one that transcends disciplines and blends cosmology, quantum physics, and philosophy into a single, confounding question. Everything we know about the universe hinges on principles like mechanism, causality, and logic. We yearn to understand why things are the way they are. And yet, when we look back to the very origin of everything, we encounter a silence, a blank slate, no explanation, no process, just an abrupt, infinite unfolding. At the most fundamental level, we simply don't know how or why the universe came into existence. But this lack of an explanation isn't for lack of trying. Scientists, philosophers, and dreamers alike have long pondered the question: what was there before the universe? Some, like the legendary physicist Stephen Hawking, offered a startling possibility. Perhaps there was truly nothing before. Not nothing in the sense of empty space, but a deeper nothing, the absence of space and time themselves. According to this idea, space and time are not separate entities, but deeply intertwined properties of the universe we inhabit. So when we speak of the beginning of the universe, we're really talking about the beginning of time itself. There was no before the Big Bang, because there was no time in which before could exist. It's like asking what's north of the North Pole. The question itself loses meaning. Hawking proposed that as we trace space-time backward to its earliest moments, we find it warping and curving inward until it smoothly rounds out. There's no singular beginning, no edge or boundary to cross, just a kind of smooth transition from non-existence to existence. From a certain perspective, the universe simply is. It didn't necessarily come from anywhere in the traditional sense. Of course, not everyone agrees. Other scientists suggest that the Big Bang was just one part of a much grander and more complex story. According to the theory of cosmic inflation, our universe underwent a split-second period of exponential expansion immediately after it began. This inflation smoothed out the universe, giving rise to the cosmic structure we see today. But some physicists believe this inflation never truly ended, not everywhere at least. Instead, they propose that inflation is still happening, eternally, in different regions of a vast, ever-growing multiverse. In this vision, our universe is just one bubble among countless others, each with its own laws of physics, dimensions, and even timelines. Some of these universes might be wildly different from ours, while others could be eerily similar. This idea, the eternal inflation model, opens the door to the tantalizing concept of a multiverse, a sprawling ensemble of universes that extends far beyond what we can observe. If this is true, then the Big Bang wasn't the beginning of everything, just the beginning of our particular bubble. Yet another theory, known as the Big Bounce, suggests something even more cyclical. According to this model, the universe didn't begin from nothing, but instead emerged from the collapse of a previous universe. The cosmos expands, contracts, and rebounds in an infinite loop. No beginning, no end. Just an eternal rhythm of creation and destruction, woven into the very fabric of existence. These aren't just fanciful ideas. They're grounded in real physics, drawn from the mathematics of general relativity and quantum field theory. And yet, no single theory has emerged as definitive. That's partly because we're limited in how far we can see. The cosmic microwave background, the faint afterglow of the Big Bang, marks the edge of our observational horizon. Anything that happened before that moment is hidden from us, perhaps forever. Still, Scientists continue to push the boundaries. New telescopes, like the James Webb Space Telescope, are probing deeper into the early universe than ever before. They are not just looking for galaxies, they're looking for clues. Clues about the first stars, the first structures, the very conditions that may reveal what triggered the cosmic explosion that set everything into motion. Perhaps someday we'll find the answer. Or perhaps we'll learn that the question itself is flawed, that there's no why to the universe, only the raw, beautiful fact that it is. Whatever the truth may be, the mystery of the universe's origin remains one of the most awe-inspiring topics in human inquiry. It invites us to peer beyond the veil of time, to wonder, and to imagine realities beyond our own. Some strange, some familiar, all woven into the silent infinity that surrounds us.